Assalamualaikum warahmatullahi wabarakatuh. We are Group 6 from the course SFU 1023 Applied Physics. So today we are going to conduct an experiment entitled Inclined Plane Motion of a Car. So without further ado, let's do it. So the objective of our experiment is to investigate the angle of inclination of a plane with a car acceleration by obtaining the velocity time graph through the tracker software. So now we are going to conduct the experiment. But first, let us introduce to you the apparatus that we will use in this experiment. So let's go.
Apparatus.
Now, I will introduce the apparatus we used along with their specific functions. Number 1. Stopper. The stopper is used to hold the toy car in place. Number 2. Inclined plane. The inclined plane provides the slope surface on which the toy car moves. We adjust its angle to study how slope affects the car's motion. Number 3. Toy car. The toy car acts as our moving object. It slides down the inclined plane, allowing us to observe and analyze its motion. Number 4. Protractor. The protractor is used to measure the angle of inclination of the plane accurately. This helps us control the variable and conduct fair tests. Number 5. Books. Books are used to elevate one end of the inclined plane, helping us set different angles for the slope by stacking more or fewer books. Number 6. Ruler. The ruler is used to measure the length of the inclined plane or the distance traveled by the car. This is important for calculating speed and acceleration. Number 7. Tracker software. Tracker software is used to analyze the motion of the car frame by frame from the recorded video. It helps us obtain data such as velocity accurately.
Procedure.
The apparatus was set up carefully before the experiment began. 1. Preparation of the rim. A piece of cardboard was used to build the inclined plane. One side was raised using booms to create the slope. 2. Object placement. A toy car was selected and positioned at the top of the cardboard rim. The car was aligned straight to avoid sideways movement during motion. 3. Conducting the trial. The car was released from rest without applying any push. Its motion down the rim was recorded in a single continuous shot.
The video recorded will be inserted into the tracker software. Then, we are going to extract all data related by using the software. All the data will then be recorded into the table. A graph velocity versus time will be plotted and will be calculate the acceleration of the car moving down the plane. That's all.
After the experiment was done, now it's time for us to extract the data from the tracker software and analyze it. So let's go. So this is the first data at angle of 10 degree. The second data at angle of 15 degree. Data at angle 19 degrees. Data at 24 degrees. And data at angle 29 degrees. Now, from all the data, we can see that the velocity versus time graph for each angle of inclination of the plane shows the relationship of velocity increase linearly with time, which means in its very own graph, the acceleration is constant, which can be found by calculating the gradient of each graph. This gives us the equation of each graph, which are all the same, which is V equals to AT. We can also see that the time taken from the car to move down the plane becomes shorter as the angle is increased, which means the acceleration increase as the angle increase, which we will be proving with calculation next. Here are all the calculation of acceleration by calculating the gradient of each graph. As we compare all the acceleration at each angle, we can see that the acceleration gradually increase as we increase the angle of inclination of the plane, thus proving our hypothesis for this experiment.
Conclusion.
From this experiment, we found that the acceleration of the car increases as we increase the angle of inclination of the smooth plane. This supports the concept that steeper slopes result in greater components of gravitational force acting along the plane, leading to higher acceleration. We successfully used video analysis tools to collect and measure motion data such as velocity and time with greater accuracy. Additionally, we were able to generate and interpret velocity versus time graphs to determine the car's acceleration at different angles. Therefore, all the objectives of this experiment were achieved.